So for concept 1, question B, we're going to need to graph this inequality. To graph something that looks like a line, such as this, we'll need to make sure that the inequality is in y equals mx plus b form, which you might remember from Algebra 1. That means we have to take this inequality and start by getting that y by itself. So if I copy down, and notice I'm just doing this in my scratch space, if I copy down the inequality, the first thing I can move should be that 8x. Since it's positive 8x, I'll move it by subtracting 8x to the other side. That would give me 4y is less than negative 8x plus 16. Notice I wrote the negative 8x first. That's to keep it in the mx plus b format that we're probably used to from Algebra 1. Now, to get y truly by itself, we need to divide by 4. But since we're dividing the left side by 4, we also need to divide the right side by 4. Since there are two terms on the right side, they both need to get divided. So keep in mind you're dividing every single thing by 4. That means our inequality now reads y is less than negative 2x plus 4 once we divide. Now that we have our inequality written out, it's time to graph. To graph, we start by plotting the y-intercept, which is always the last number, the number not attached to the x in the original inequality. So since that y-intercept is positive 4, on the y-axis, remember that's the vertical one, we go up 4 units and we make a dot. Now, from that dot, the slope should tell us where to go next. Slope technically should be a fraction. Some of us might remember the phrase rise over run. Rise tells us how far up to go. Run tells us how far to the right to go. If for some reason you're dealing with something that's not a fraction, like negative 2, you can assume it's to be written as negative 2 over 1, which means we rise negative 2, we run 1. That means from our y-intercept, rise negative means down 2 to the right 1. To make a super straight line, we can keep making dots down 2 over 1, down 2 over 1, until you get enough dots that you can get a straight line from. Before we draw the line, we do need to consult our inequality. This was a less than. So to make sure, we need to use a dotted line to indicate less than, not less than or equal to. There's no little line underneath the inequality. We're nearly finished, but we need to tell the graph to show only the values that are less than this inequality. So since the little mouse, some of us call it, since that little inequality is facing away from the y, that means we're only shading the values that are less than y. So if you want to start at the y-axis where you plotted your point, the values that are less than would be the values below the line. So we're just going to lightly shade, neatly but lightly, that entire region below the line, which means now we have what's called our solution set. That entire shaded region represents all of the values that could possibly work for this inequality. That means it's going to help us when we answer the second part of this question. Is negative 2 comma 3 part of the solution set? The easiest way to check is to simply check your shaded area. If I start at 0 and go to negative 2, positive 3, I can see that that point is definitely included in the shaded area, which means yes, it's part of the solution set. When it's asking you to say the reason why, you can simply write because it's in the shaded area. Another way to do it is to take the x-coordinate, negative 2, to take the y-coordinate, 3, and to plug them into the original function. If the original function on the left comes out to be less than 16, then yes, it's part of the solution set. But since we have the graph already done for us, I think you'll agree, this graphing part goes a lot faster than plugging in.